Have you ever pondered the limitless potential of artificial intelligence in the realm of gene editing? Well, we are about to dive into this fascinating intersection where cutting-edge technology meets the intricate science of our genetic makeup. Our journey begins with an introduction to gene editing. Imagine the genes in our body as an intricate blueprint, dictating everything from our eye color to our susceptibility to certain diseases. Gene editing, in essence, is the ability to rewrite this blueprint, to erase genetic mistakes, or even add new elements. It's a science that has the potential to revolutionize medicine as we know it. Now let's bring artificial intelligence into the mix. AI has already made waves in various sectors, from composing music to making investment decisions, but its potential extends far beyond these arenas. Today we're talking about a field where AI is not just a tool, but a game changer: gene editing. Enter Profluent Bio, a trailblazing company based in California, that has designed a system that combines the power of AI with the promise of gene editing. This system is not just an incremental improvement on existing technology, it represents a paradigm shift. The AI at the heart of this system, much like a virtuoso composer, doesn't just play the existing notes, it creates new ones. By developing molecules that have never existed in nature, it opens up a world of possibilities. These are not just any molecules, but ones that can edit human genes, potentially paving the way for bespoke cures for diseases. This is not a theoretical concept or a distant dream. The AI-made gene editors have been tested in human cells, demonstrating impressive levels of functionality without causing unintended changes in the DNA. As we stand at this crossroads, we witness the dawn of a new era in medicine, one where AI becomes an architect of cures, designing molecules never seen before in nature. This revolutionary system is capable of creating unique, never-before-seen molecules, opening up the potential for a range of bespoke cures for diseases. So, buckle up as we delve deeper into this fascinating intersection of AI and gene editing. So how did this AI acquire the knowledge to edit human genes, you might ask? Well, it all begins with a process called training. Much like how a child learns to read or write, the AI was taught using a colossal database, but instead of words and numbers, this database was filled with 5.1 million CRISPR-associated proteins. These proteins, known in the world of molecular biology as CA's proteins, are the building blocks of the revolutionary gene editing technique, CRISPR. By exposing the AI to this vast array of proteins, the system was enabled to understand and create potential molecules that could be used in gene editing. Now, imagine being given millions of puzzle pieces and asked to create a masterpiece. That's exactly what this AI had to do. Out of the initial 5.1 million proteins, the AI had to narrow down its options to just 4 million sequences. This was no easy task, but the intelligent system was up for the challenge. Within these millions of sequences, the AI identified a particular gene editor. This wasn't any ordinary editor, it was a new player in the field, christened as OpenCRISPR-1. This AI-created gene editor held the potential to revolutionize gene editing as we know it. Why, you ask? Well, OpenCRISPR-1 had a unique capability. It performed just as well as the natural CA's proteins, but with a significant advantage. It greatly reduced the impact on off-target sites. To give you an idea of how impressive this is, consider this. When editing genes, it's crucial to avoid altering unintended parts of the DNA. This is because such off-target effects could lead to unwanted side effects. OpenCRISPR-1, however, managed to cut down these off-target impacts by a whopping 95%. So, in the vast universe of gene editing, this AI carved out its niche, learning from millions of proteins, selecting the most promising sequences, and finally creating a gene editor that outperforms its natural counterparts. It's truly remarkable, isn't it? How an AI system can outperform nature, reducing the impact on off-target sites by a staggering 95%. Now, gene editing isn't a new concept, so what sets this AI-designed biological system apart? This question takes us back to our existing gene editing techniques. Chief among them is the Nobel Prize-winning CRISPR, or Clustered Regularly Interspaced Short Palindromic Repeats, if you're into the whole formal name thing. CRISPR, in its essence, is a revolutionary technique that can edit the genomes of living organisms. Think of it as a pair of molecular scissors, if you will. It can cut a cell's genes or add new ones, altering the very fabric of life. It's like rewriting the code of life, enabling us to correct genetic defects, treat and prevent the spread of diseases, and improve crops. This technique has been used to alter genes that cause hereditary conditions. Take sickle cell anemia, for instance, a condition where there aren't enough healthy red blood cells to carry adequate oxygen throughout your body. or certain forms of blindness that are passed down through generations. CRISPR has shown promise in tackling these conditions by editing the problematic genes. But here's the catch. CRISPR has always relied on gene editors found in bacteria. These are naturally occurring proteins that bacteria use as a defense mechanism. They are, in essence, nature's own gene editors. However, nature's tools, as fascinating as they are, come with their limitations. They are not always as precise as we would like them to be, and there's always the risk of off-target effects, where unintended parts of the genome are altered. But with the advent of AI, we're no longer reliant solely on what nature provides us. We're stepping into a future where we can design medicines precisely according to our needs. And that, my friends, is where the real magic lies. The fusion of artificial intelligence and gene editing holds the promise of a future where diseases are not just managed but cured, and where our knowledge of biology is not just based on what we find in nature, but what we can create ourselves. So, where does the future lie for this union of AI and gene editing? Well, allow your imagination to take flight as we delve into the potential implications of this groundbreaking technology. In the grand scheme of things, AI is poised to serve as an interpreter to decode the language of life. Imagine a world where diseases are no longer a life sentence, but merely a temporary setback, something that can be edited out of our genetic code. This is the future that Profluent Bio envisions, a future where AI and gene editing go hand in hand, working together to eradicate diseases that have plagued humanity for centuries. The possibilities are truly staggering. With AI's ability to sift through millions of data points and identify potential cures, we are inching closer to a world where genetic diseases are a thing of the past. From sickle cell anemia to hereditary blindness, the list of conditions that could potentially be cured by this technology is endless. But what's even more exciting is that this isn't just a pipe dream. It's happening right now. Clinical trials are already underway, testing the efficacy of CRISPR technology in treating human genetic diseases. Each successful trial brings us one step closer to a future where diseases are not just treated, but cured once and for all. Yet, as with any new technology, there are challenges to overcome and ethical considerations to grapple with. One of the key challenges is ensuring that this technology is used responsibly and ethically, but the potential benefits undoubtedly outweigh the risks. And with careful regulation and oversight, we can ensure that this technology is used to its fullest potential, without crossing ethical boundaries. As we stand on the precipice of this new frontier, one thing is certain: the potential of AI and gene editing is boundless. We are on the cusp of a new era in medicine, one where diseases are not just managed but cured, one where the human genome can be edited and perfected, all thanks to the power of AI. The future is not just promising, it's exhilarating. In the end, what does this mean for us and the future of medicine? We are standing on the precipice of a new era, where artificial intelligence doesn't just suggest recipes or compose music, but has the potential to alter the course of human health. The innovative work of Profluent Bio, a California-based company, has laid the groundwork for this future. Their system, trained on a database of over 5 million CRISPR-associated proteins, can create molecules not found in nature, ones that can be used in gene editing. This isn't just an incremental improvement on existing techniques. This novel approach to gene editing, embodied in their open CRISPR-1, doesn't merely perform as well as existing CA's proteins, it also significantly reduces the impact on off-target sites by an impressive 95%. This breakthrough could potentially eliminate the current limitations of gene editing, opening up new avenues for curing diseases. The implications of this technology are profound. It holds the promise of not just treating, but curing even the rarest of diseases. This goes beyond just the potential of addressing hereditary conditions like sickle cell anemia or blindness, conditions that have been the focus of CRISPR techniques so far. We're talking about a future where AI can design bespoke treatments, tailored to individual needs to tackle thousands of currently incurable diseases. This breakthrough is a testament to the power of AI in advancing medicine. It shows how AI can act as an interpreter, decoding the language of life. By training large language models on massive amounts of genetic data, we can push the boundaries of what is possible in biology. We can move from being constrained by what nature can offer, to designing new medicines precisely according to our needs. As we continue to push the boundaries of what we know and what we can do, one thing is clear: the future of medicine lies in the hands of AI.